So for this next video, we'll be going over the conservation of energy and potential energy and kinetic energy equations. So, to begin, we'll start with kinetic energy. Kinetic energy, which is 1/2 mv squared. Right? So, example of kinetic energy would be just something moving, and potential energy is mgh. So that's potential energy. An example of that would be, say someone's holding up like a ball like 10 feet above the ground. The potential energy is the energy that it has when it's released. Yeah, because if it's released, it'll just drop straight down and move. So now we're going to talk about the conservation of energy. So for the conservation of energy, the idea is that no energy is ever lost. So kinetic energy can become potential energy can become kinetic energy, but it's never lost. So we can model that by writing the equation 1/2 mv squared plus mgh equals 1/2 mv squared plus mgh. Right? So all we're saying is that the sum of the potential energy and kinetic energy before will equal the sum of the potential energy and kinetic energy after at any time. So now we can use that when we apply it to the next problem. Example 11. So the problem is a 2 kilogram object is released from rest of a height of 3 meters above the Earth's surface. How much kinetic energy does the object have when it reaches a height of 1 meter? So, just an important note is that when we're talking about potential energy, and which equation is mgh, we're almost always just going to assume that the gravity is 9.81, which is 10, and that it's in a close proximity to the Earth's surface. So, now what we're going to do is we're going to use the initial values that they gave us. So, it's 3, the object is at rest. So the object's at rest, so velocity 0, so 1/2 mv squared. Here they give us the mass, which is 2, 1/2 times 2 times 0 squared, so that will eventually cancel out, plus mgh, 2 kilograms, height 3, and then and then g 9.81, but we approximate as 10, and that equals, because we use our conservation of energy equation, that equals 1/2 times 2 times v squared plus what they gave us. So it's at a height of 1 meter now. So it's just going to be 1 times 2, which is m, times 10, which is g, right? So we can cancel that out. So on this side, it's going to be 60, which is just the potential energy. That's all that is potential energy. 60 equals 1/2 times 2 times v squared. So that simplifies just to v squared. And then plus 1 times 2 times 10, which is 20. So we can simplify this. And remember, that's potential energy. This is potential energy as well. And then this is the kinetic energy element. So we can write that. And then now all we do is subtract 20, the potential energy. So we get 40 equals v squared, and that's what the kinetic energy component is. So we have kinetic energy when it reaches a height of 1 meter equals 40 joules. Joules is the unit. Yep. And as we can see on the answer sheet, that is answer choice C. So 40 joules.